stay away from there.
Especially if you're an agent and they know you're a police officer too.
No, they won't know, that's the key. They will not know.
All right, so we've talked about the sales comparison approach. Which two types of property did I say you use that to value?
Residential and vacant.
Residential vacant land, absolutely. So now we want to move on to the second way of valuing property. And I will tell you, based on previous experience, that the last two methods of valuing property give people many more problems than the first one. The first one is one that generally people are okay with on the exam. The next two are ones that not so much. Primarily because they're not as obvious, they have more steps along the way. The cost approach is used to value special use properties, the ones that aren't residential, don't produce income. Those are the kinds of properties that we're going to use the cost approach for. And you need to learn the steps that I'm going to give you that go along with this, because it has to be done in a certain order. None of these are complicated, but if you don't remember the steps, you'll never get to a cost valuation. Okay? So, when we value things using the cost approach, and by the way, this is the least accurate method of valuing property. We just don't have any other way to do it. So why do we need to value something like a fire station or a library? We're going to pay taxes on those properties. We're going to pay taxes. What do we need a value for them? Can a library blow down in a tornado? We need a replacement cost. We need insurance on these things. So we need to have a value for insurance purposes, if nothing else. So when we talk about the cost approach, keep in mind that this is just for reference purposes. This is in case something happens to that property, all right? So the steps to determining a cost value. Number one, don't use the cost valuation. Number one is value the land separately. Value the land separately.
Cost approach, right?
This is the cost approach. But you value the land separately as if it is vacant. Have we said something about valuing vacant land today? What approach to value do you use to value vacant land? The sales comparison approach, the CMA approach. So the first step to the cost approach really is don't use the cost approach. The first piece of the puzzle is going to be treat the land as if it's vacant, as if it's empty, and then you use the sales comparison approach to value the land. So find other pieces of vacant land that have recently sold and come up with a value for the land separately. Does everybody follow that? So, step number one, plus, it's a math equation. Step number two, determine a replacement or reproduction cost for the improvements. What do we mean when we say the improvements? Buildings. So let's talk about the difference between replacement and reproduction cost. In your book, and it's on page 404, they give you an idea of replacement versus reproduction. They are two different things. Two different things, two different methods. One not very commonly used and one used almost all the time. So here's the difference. Replacement cost is figuring out how much it would cost to replace that property with a similar but modern structure. In other words, you had an 8,000 square foot office building, we're gonna replace it with an 8,000 square foot office building, but we're gonna use today's technology, today's features, today's whatever. Or reproduction cost. We're gonna figure out exactly what you had, down to the type of brick, the type of mortar used, the paint colors, the building materials, and we're gonna reproduce it exactly as it originally stood. First of all, which one of those sounds more expensive to you? Reproduction.
Oh, because.
Because we gotta produce it exactly as it was. We gotta find all those exact materials and specifically use those kinds of materials to reproduce it exactly as it was. When would that be useful? What kind of property would that be useful for? Historic properties. With historic properties, we use reproduction cost. For everything else, we use replacement cost. Does everybody see the difference between the two? So replacement cost just replaces it with the same type structure, but using today's building practices. Reproduction cost reproduces it down to every nail, every board, exact same structure, reproduced again, no matter what the cost is to do it. So you see why we want to use replacement versus reproduction in most cases. Has everybody got that? So now let's talk about the way you calculate a replacement cost. They give you three methods up here, but I'm going to tell you one's the one you got to be aware of. The first one up there, the square foot method. 99 times out of 100, 99 times out of 100, you're going to be talking about the square foot method. Well, we just did this almost in the sales comparison approach. We were doing dollar per square foot. That's what the square foot method is. You come up with a replacement dollar per square foot, and you just apply that to the number of square feet of the building. Say if we were replacing this office building, it could burn down, and we were using a replacement cost for insurance purposes, we might find that in the area, the cost of building office space is $60 a square foot. So you would simply take the square footage of the building times $60 a square foot, and that's its replacement cost. Does everybody follow that so far? I'm sorry?
Take the what?
Take the square footage of the building and multiply it times $1 per square foot replacement cost. So if the replacement cost in the area for office space was $60 a square foot, and the office was 10,000 square feet that burned down, the replacement value would be $600,000. 6,000 square feet times, $60 a square foot times 10,000 square feet.
They wouldn't do that for this building, this commercial. This is the only way they do this for.
Special use. Special use. But just to give you an
Yeah,
idea
no,
of how it works. Is everybody with me so far? Now, we're not through. One more step. So we start with the land value plus replacement cost. Here's the thing though. Remember, this is for insurance purposes, right? In most cases. If you're the insurance company and a church comes to you and they're using a 60-year-old warehouse building as a worship facility, right? And it burns down. You're going to look at replacement costs for a brand new building for them? Is that what you're going to insure? Why not?
This is a part of them.
Because it's a pretty good size. It's cruddy.
It's cruddy. Why is it cruddy?
Old.
Old. There's a word for old in real estate, a fancy one. It's called depreciation. So when we do the cost approach, we take the value of the vacant land and we add the replacement cost of the building, but then we have to subtract depreciation. Yes, sir. Yeah, the, unit on the front of the building isn't coming on, so the thermostat that's in that big room over there, yeah, they couldn't get it to do anything.
Thermostat's lit up and it's working.
Thermostat's lit up working, but the unit's not coming on at all. Yep, thanks. Everybody got those 3 steps? That's how you do a cost valuation. Value the land as if it's vacant, using the sales comparison approach. Boom, $50,000. I'm just making up numbers, right? You understand that? Replacement cost of the building, 10,000 square feet at $60 a square foot. So that's plus 600,000, right? Good on that? So far, what are we at? $650,000. But we have to subtract depreciation for that building. Okay? So let's say that the building is 20% depreciated. So we would be subtracting not 20% of 650, because land never depreciates, right? We're only depreciating the improvement itself. What's 20% of $600,000? 120. Minus $120,000 in depreciation. So what would be our cost value of that property? 650 minus 120 is 530. Does that sound about right? So our cost valuation of that property would be $530,000.
Now that's easy math. Now how do we determine those numbers?
That's where it gets a little more complex. Not a lot more complex, but just a little bit more. Really, the only thing we haven't talked about yet is the depreciation piece. Replacement costs, we just did the numbers of. It's the depreciation piece we haven't. Because it won't give you, it won't just say 20%. That's too easy. But does everybody understand the basic steps that are involved here? It really is no more complicated than that. That's the key here. So understand, you have to take those 3 steps. Value the land vacant, add the replacement cost, and I just say replacement. It could be replacement or reproduction, but 99% of the time it's replacement. So vacant land value, using the sales comparison approach, plus the replacement cost, minus the depreciation. And that's your cost valuation. Okay, has everybody got these 3 steps? All right, so let's talk about that depreciation piece and how we calculate it. It's in your book on page 405, and I'm going to come back here in just a second and talk about these other 2 methods of doing replacement costs other than the square foot method, but while I'm on this train here with the math, I want to keep it up. Okay, so we're going to jump just ahead a little bit. We're going to talk about the depreciation. The most common type of depreciation that you're going to get as far as math goes is something called age life or straight line depreciation.
So there are 2, they're both the same. There's 2
Sorry?
different things. There's 3, age, life, and straight line are different.
No, they're the same thing. Age life done with a straight line depreciation. Okay, so what that means is the property is depreciating at a steady rate over time, a certain percent per year. The problem is it's not usually expressed as a certain percent per year. Does everybody follow me on that? So let's talk about how you come up with your depreciation rate and how much it's depreciated, right? Every property has something called its economic life. The economic life is the amount of time you expect that property to be useful for its original purpose. That is very different than its actual life. Its actual life is the amount of time it will remain standing. So the economic life is going to be much shorter than And here's how you know that. Don't most buildings have some period toward the end of their life where they're just empty, vacant, nobody's using them? So their actual life continues on, but their economic life has ceased to exist. Does that make sense for everybody? So the economic life is the amount of time where we expect a building to remain economically useful for its original intended purpose. By the way, what city has the shortest economic lifespan in the world?
What city?
I'm sorry? What city? Shortest amount of time you would expect a property to remain economically viable. Sin City, baby. Las Vegas.
Really?
Build them, use them 15, 20 years, blow them up, and build another one.
Oh, yeah.
Shortest economic lifespan by far for commercial property in the world. And it's not uncommon to see 20-year-old buildings imploded there, brought down, right? You got other cities, buildings are there for 100, 150, 200 years in some cases. Not in Las Vegas. Blow it up, bring it down, build another one right in its place. Shortest economic lifespan in the world is in Las Vegas. That means as an investor, you've got to capture that money much more quickly because it's not going to be there long. It's not going to be economically viable for very long. But, so the economic life is really important when it comes to depreciation because that's what we base our depreciation on. All right? Now, we also have something called effective age. And the best way I can think of to describe effective age is the amount of useful years that have been used from the property. What I want to point out to you is the effective age can be changed. If we don't do maintenance on a property, would you agree it declines more rapidly than if we do? So what we can do is effectively age a property faster than its actual age. Property could be 10 years old, but could have an effective age of 20 years because we haven't done any maintenance on it. The reverse is also true. If we go into a property that's 30 years old and we gut and renovate and change and update, haven't we changed it? Haven't we rolled the clock back on its effective age? The key here is the economic life stays the same all the time. What changes is the effective age. So if the economic life is 60 years, it's always 60 years. But we can move the effective age forward or backwards based on our activities. So it's not the actual age. And I know that gets confusing for people. But you can move that effective age forward or backwards based on how you maintain or don't maintain the property. The way depreciation is going to be expressed a lot of times is some comparison of the effective age and the economic life. The property's effective age is 12 years. And it has an economic life of 60 years. Well, that's 12 of 60. 12 divided by 60. Effective age, economic life. Everybody got that? And if you wanted to really make it into a math equation, the effective age divided by the economic life, that equals your percent depreciated. So if we have that property right there that has an effective age of 12 years old with an economic life of 60 years, punch that in your calculator, 12 divided by 60. Now remember, that's a rate you're calculating, right? Depreciation is a rate. Whenever we calculate a rate, what do we have to do with our answer? Multiply by 100. So 12 divided by 60 times 100. What is our percent depreciated? 20%. We have 20% of the useful economic viability of that building is gone. Which means what percent's remaining? 80%. That building has lived 20% of its useful economic life. It has 80% of its useful economic life remaining. Does everybody see the difference there? So when you get this effective age and economic life, all you gotta do is divide the two, and that'll give you your depreciation.
Because that was effective age and your economic life.
Effective age divided by economic life.
And they're given or we have to?
They're gonna give you the economic life.
Okay.
Let's say the property has an economic life of blank years. Or the property is expected to remain economically viable for 75 years. Well, you have to, that's the economic life.
Can we calculate effective age?
Well, and then they might say, the property has 25 years of its expected 75-year economic life remaining. What was the economic life? 75. And what did they say about it?
25 years
It
left.
has 25 years remaining, right? So is the effective age 25 or is the effective age 75 minus 25?
Yes.
The effective age would be 50 because it has 25 years remaining.
The effective age has always happened, has already taken place.
Has already taken place.
Okay.
Right, it's the flip side of what's remaining, right,
And
exactly.
that was 50 divided by 75.
So that would be 50, so the effective, the percent depreciated of that would be 50 divided by 75, which is 67%, right?
Right. So obviously the closer those numbers, the older the
That's right, exactly, and the less time it has remaining as an economically viable property. The closer those numbers get to being the same, the less time remaining that property has. When a property's brand new, it's at 1 over 75, you know? 2 over 75. Or if you're in Las Vegas, 1 over 20. Does everybody see that? So that's going to be the rub of the math problems with the cost is coming up with the right depreciation component to subtract. All right, go back to your handout that I gave you. And let me make sure I give you the right one. I didn't give you a cost one. Why didn't I give you a, hang on. I have one. I know I have one. You did it again. You did it again. Okay. Very simple one.